Kuti sir, shall we start now?
Oh, yes, it is. Oh, yes, it's time. Okay.
Okay. First of all, with a hearty wishes to all women over there, we wish you a happy Women's Day. And let me start our today's session with Rishika, who is a prodigy of your Space Club. Rishika, over to you.
A warm good afternoon to everyone present over here. It is a privilege to welcome you all to the 76th webinar session of the UL Space Club, a platform dedicated to fostering curiosity and knowledge in the realm of space science and technology. Before we begin, I would like to extend a heartfelt gratitude to the esteemed individuals who have been instrumental in guiding and mentoring this initiative. Firstly, a warm welcome to Sri E.K. Kutte sir, the visionary founder and mentor of UL Space Club, whose unwavering dedication has been the driving force behind this platform, inspiring countless young minds to explore the vast frontiers of space. We are deeply honored to acknowledge Sri Jairam sir, former director of ISRO, whose valuable guidance has enriched the UL Space Club, providing students with inspiration and direction in the field of space exploration. Along with him, we extend sincere appreciation to Sri Jyoti Basu sir, a guiding personality whose contribution and mentorship have significantly supported the growth and learning of our Space Club members. A special mention to other ISRO veterans and space science experts who have been a source of support and mentorship, shaping the learning journey of students at UL Space Club. Moving to the core team, we have Mr. Varun, the team lead for overseeing the smooth execution of this event, Mr. Sriram, the webinar head for coordinating and managing all aspects of this session, Mr. Abhinand, the curation coordinator for ensuring that the content and flow of this session meet the highest standards of engagement and learning. We also extend a warm welcome to Ms. Shruti, our moderator for today's session, who will be leading this discussion, ensuring an interactive and insightful exchange. We are privileged to have Ms. Arya Raj, a fourth year BS-MS student at IISER Thiruvananthapuram, as our speaker today. With her expertise in planetary science, she will guide us through the complexities of planetary environments and what makes a planet capable of supporting life. We encourage all the participants to actively engage, ask questions, and make the most of this learning opportunity. Without further ado, let's begin this exciting session. Over to you, Ms. Shruti.
Good evening, everyone. A warm welcome to the 76th section of the UL Space Club webinar series. Our club motivates and trains the young children in space science, astronomy, and space technology. We conduct many activities, including space camps, sky safari, etc. Today's section is extra special as we celebrate International Women's Day by inviting a remarkable woman to share her insights. We are honored to have Ms. Arya Raj, a fourth year BSMS student at IISER Thiruvananthapuram, as our speaker. Despite facing physical challenges, she has shown great perseverance and dedication to her passion. Her resilience and passion make her the perfect speaker for today's session. Specializing in physics with a minor in biology, Arya's passion for astrobiology drives her research in biology, physics, and space science. Her work spans diverse areas, including bacterial survival in space, spectral analysis in gamma rays bursts, and exoplanet studies using radial velocity data. Arya is skilled in computational methods, programming, and data. She has presented her research at international conferences and earned prestigious accolades, including the Inspire Scholarship and recognition in the India Book of Records 2023. Her goal is to contribute to planetary science and space research, and traveling the mysteries of life beyond Earth. The topic of today's session, decoding planetary secrets, atmosphere, surface, and habitability, is deeply relevant to understanding the conditions that make planets habitable. As we search for life beyond Earth, studying planetary atmospheres and surface helps us uncover the essential factors that shape their potential for life. I hope this session will be insightful and valuable to all of you. Without further ado, let's welcome Arya Raj to lead us through this fascinating topic.
Before moving to Arya, I would like to request participants to switch off their camera throughout the session and also switch off the mic so that students can easily listen to Arya's presentation and they can listen to Arya's screen as well. So when Arya is sharing her screen, her presentation, other students, please don't try to share your screen. It will be an interruption to other students when they are listening to this. So if any of your friends missing today's webinar, we will record the session and we will stream it in the YouTube so they can access the session through our YouTube channel as well. So these are the instructions. So without any delay, let me move to Arya. Arya, over to you.
So, thank you for the opportunity to give me a session for the webinar. I will share my screen.
Okay, Arya.
Okay.
Yes.
Today we are going to discuss about the characteristics of the planet, especially the atmosphere, surface, and the potential habitability. It, it is basically I have planned interactive session. So if you have any doubt, feel free to ask. Okay?
Okay, Arya.
So the understanding of planetary atmospheres and surfaces is the key to understand the planetary evolution and potential habitability. Atmospheres can regulate climate, surface conditions, and energy balance, betting whether life can exist in a planet or not. This is the key questions that we are going to ask in this presentation, that we are going to discuss in this presentation are like what are the key factors that make a planet habitable, how the planetary surface evolved, and what do the atmosphere's role in the planetary dynamics. These are the questions we will address in this presentation. So, before going to that, we can classify the planets based on the two criteria. One is combustion, and the other one is the habitability. Based on combustion, we can classify the planets into three: terrestrial or rocky planets, gas giants, and ice giants. The rocky planets are composed of silicate rocks and metals. They have a solid surface with a thin atmosphere. Sometimes they may not be atmosphere. They have high density crater surfaces, meaning that asteroids invert on the surface. They create craters and all. And the other category is the gas giants. Gas giants are mainly composed of hydrogen and helium. There is no solid surface in gas giants. Is there any question? There is a hand raised sound or something.
Uh, like Arya suggested, if any other students have any questions about what Arya is presenting about, they can type their question in the chat window, or they can raise their hands with the Google Meet tool, and they can ask it directly to Arya.
Yeah,
Uh,
fine.
yes. Arya, you may continue. As soon as there is a question, I will also make it to your notice.
Yeah, fine. They have thick atmosphere with dynamic weather system. We are talking about the gases. So they have a large mass and radius compared to the terrestrial planets. They have a strong magnetic field and high gravity, and also the rapid rotation. Accidents are quite comparable with the gas giants. They contain more ices like water, ammonia, and methane. Methane gives them the bluish color atmosphere. They have less hydrogen and helium compared to gas giants. They are similar to gas giants in the perspective of combustion, but when we come to internal structure, they are called rocky planets. They have atmosphere, mantle, and core as compared to rocky planets. In addition, rocky planets have oceanic as well as continental crust. Apart from that, the gas then have clouds, gases, hydrogen, liquid hydrogen layer, and metallic hydrogen layer, and a core. Core is thought to be in the soil. Only solid parts in the gas giant. Rest or at liquid or molten state. Then we can come to the habitability potential. Based on the habitability potential, we can classify the planets into three. The habitable zone planet, which is orbiting in the Goldilocks zone, means the water can be exist in the liquid form. They have high potential to habitability. Greenhouse effect like carbon dioxide, water vapor, etc. can be expand the habitable zone. The other category are the ocean worlds. Planets that may have subsurface oceans beneath the ice crust. In the satellite of Jupiter, like Europa, Callisto, etc., they have subsurface oceans beneath the high dense crust, like ice crust. There are also planets with surface oceans like Earth, where the life can where the water exists in the liquid form at the normal atmospheric pressure. They, they also have a chance to habitability because life is first originated in water moon in the sea. Then the other classification is the super-Earths. Super-Earths are the rocky planets rather than Earth. They have 1.2 to 2 times that of the radius of the Earth and 2 to 10 times that the mass of the Earth. They have thick atmosphere and higher gravity, affecting the climate and the potential for life, especially when it is orbiting in the red dwarf planet. We can quickly go to the planetary atmosphere first. Planetary atmosphere.
Arya, there are a couple of questions. Would you like to take it now or later?
It can be taken later because
Okay, Arya. Okay. You may continue.
the story of atmosphere. Atmosphere can form to the gas capture, volcanic outgassing, and interaction with the solids. The composition with, of the atmosphere will vary based on the planet size, gravity, and distance from the star. It can be classified the atmosphere according to the evolution of the planet. planetary atmosphere can be classified into two: primary atmosphere and secondary atmosphere. The primary atmosphere is formed from the stellar nebula during the planet's formation. It is dominated by hydrogen and helium. Like in the gas cells, they retain the primary atmosphere. But in terrestrial or rocky planets, primary atmosphere can be lost. Then the secondary atmosphere formed after the primary atmosphere is lost. It is mainly in the terrestrial planets. The volcanic eruptions release carbon dioxide, water molecule, silicon dioxide, and methane can be present at that atmospheric constituent. They are created thick atmosphere on Venus and Mars are the examples of the secondary atmosphere. We can discuss the factors that are affecting the atmosphere. The gravity is stronger. One second. There is a slight delay.
Varun, any problem?
Sir, I think Arya is trying to change the slide.
Okay, okay.
Yeah,
Okay,
okay,
no
okay.
problem.
I was drinking water.
That's okay, Arya. No problem.
Hope that slide is visible.
No, Arya, not yet. Yes, it's visible.
So we can discuss about the factors that affecting the atmosphere. The gravity is the primary cause that affects the atmosphere. When the gravity is stronger, it retains more gas. The next thing is the stellar radius. Stellar radiation that remove that this the atmosphere affecting the climate. Thus, that it affects the atmosphere very badly. The magnetic field protects planets from the stellar radiation or stellar winds. The surface activities are the other influencing factors like volcanoes, water cycle can be influence the atmosphere. In some planets, atmospheres are lost. It is mainly due to the thermal escape, light gases like hydrogen, helium, escape into space. The next thing is, as I said earlier, the solar wind can wipe out the atmosphere of the planet. The craters that can remove atmospheres that are chemical reactions such as surface absorption. For example, carbon dioxide locked in rocks on Earth can be a cause of losing of atmosphere. So we can go to the story of planetary surfaces. Here we are considering only rocky planets since they only have a solid surface. The rest of the planets like gas giants and ice giants, they do not have a solid surface. So we are considering only the rocky planets here. The geology shape the planetary surface over time. The process includes volcanic activities, the plate tectonics, erosion, and asteroid impact, which is discussed detailedly later. The surface can provide clues about planetary history and habitability. This is the picture taken by the Venera mission in Venus. This is the Mars picture taken by Curiosity. There is a exciting news recently. They what evidences in Martian ocean that had existed very long ago. The research was done by Chinese observatories by analyzing the data of slow lava in the region of northern hemisphere of Mars known as Utopia Peninsula. It is very exciting thing that there were oceans in Mars long ago. Then we can discuss about the processes of planetary dynamics, like volcanism. Volcanism is responsible for resurface planet and releasing the atmosphere gas.
Arya, your mic is mute, Arya. Yeah, now it's okay.
When the mic was mute,
Just less than 1 minute.
oh, that the plate tectonics we are discussing about the processes that happen in planetary surface. The second one is the plate tectonics. Plate tectonics is a important phenomena because the crust are divided into certain plates, and since the mantle is in the liquid state, crust are the plates are floating in the mantle layer. So it creates movement of the plate, create the mountains, valleys, and the slope like this. When here, when the plates are moving apart, there will be a surface will just happening, like here when the plates are colliding each other, there will be one plate will be upper and the one plate will be lower side. So we create a mountain formation. In some planets like Venus, there is surface deform, but lack clear plate tectonics. The next thing is the erosion and weathering. Atmosphere, wind, and water shape the planetary surface. The inert water, and wind constantly resist the surface. In Mars, Venus, etc., the dust storms erode the features over time. That is known as weathering. Uh, in this phenomena, there is an important law in the inner heat that drives volcanic and tectonic activities. Large rocky planets like Earth and Venus retain more heat and have strong geological activity. Small bodies like Moon and Mercury, they are cold from inside and become geologically inactive. Then we can go to the habitability, the factors affecting the habitability. A habitable planet, which means is that the condition at which liquid water and the life as we are looking for aliens who can live in the Earth-like habitat. Because we are not looking for the habitat, which is the extinct condition. We are looking for that Earth-like planets, how the life can be formed in the Earth-like planets. The factors include the distance from the star, atmosphere, and magnetic field, like and chemical composition are the factors we can look at one by one. The light locates in the galaxy. The distance between the stars located in the middle of the galaxy is less than that of the intermediate system. They have high energy and low. The planet in the middle of the galaxy has low metallicity. The stars with more heavy planet elements are more likely to have giant planets like gas giants, ice giants, etc. Then the other factor is the size of the planet in the habitable zone. As I said before, the habitable zone is the area under which water can be situated in the liquid zone. The elements of low mass like hydrogen and helium are very low in the intermediate sized planet like Earth. In high sized planet in the habitable zone, low mass elements cannot be eliminated out. Hence, it is its atmosphere will be highly thick, highly dense. In low mass planets in the habitable zone, all the elements may escape due to the low gravitational force. So there may not be atmosphere. Atmosphere is an important thing which the life can be supported. The next thing, as I said, the magnetic field. Magnetic field prevents stellar wind. But it is formed due to the rotation of the planet. The inner core containing iron must be in the molten state to produce a magnetic field. When the high energy particles from the solar from the sun will reach the Earth's atmosphere, the electrons in the atmosphere will be go to the higher energy state. When it return to the initial state, it will release energy in the form of light, visible light. So the light in the sky in the polar region look beautiful. It is called aurora borealis. We can see how beautiful it is. The presence of the large moon is the other important criteria. The Earth in Earth has a larger moon compared to the other planets with respect to the size. The rotation of the moon thereby maintain a steady axis with respect to Earth. This is known as axis stabilization. If the inclination is very large, the system will collapse and the habitability situation cannot be maintained. This happens in other planets due to the absence of moon and or the presence of lower sized moon with respect to the size of the mother planet. The unfortunately we do not find any moon orbiting the uh, exoplanet. It is the current area of research and the telescope like James Webb are constantly looking for the moons in the exoplanet. We hope that in the upcoming decades we discover the moon orbiting the exoplanet. The other important characteristic is that the orbital features. The orbit of Superman were found to be nearly circular on a statistical analysis. They are also in the same plane in the planetary system. The observation is that they have similar planet size and the spacing between the orbit, like the graphics on the system, the spacing between the two planets are almost similar compared to the all variety. Then I wish to. It is very exciting for me to introduce to you about my internship work and the final semester in IISD. The internship work was the characterizing the exoplanet to the radiology method. There are also other methods like transit photometric methods, astrometry, etc. But we are using the most common method, that is the radiology method, to analyze the characteristics of the planet. Even the galaxy B. This method is based on the fact that the star does not remain completely stationary when it is orbited by a planet. The star moves even so slightly in a small elliptical path corresponding to the gravitational depth of its planet. It helps to predict the mass and the orbital speed of the planet. A model of how the radial velocity of the star varies with the true anomaly and type can be generated, and using this model we can determine whether a planet revolving around a star or not. The planet that the star that I look forward is the Thiruvananthapuram. It is located in the constellation of Pegasus. By observing the radial velocity spectrum, this of this star and analyze it with the model, it is possible to determine the properties of the planet, even the galaxy B, such as its mass, time period, etc. Before going to further, we can look at the orbital properties, orbital parameters that they use to create the model. True anomaly is the phase we can say. It is the angle between the current position of the orbit and the closest point to the center of the orbit. This is the angle called true anomaly or phase. The inclination is the angle between the of plane of the observer and the orbital plane. Reference plane and the orbital plane. Then the angle of periapsis. This is the angle between the direction of ascending north and the direction of periapsis. This is the model with varying eccentricity. So anomaly versus velocity is plotted using this equation, where theta is the true anomaly or phase, omega is the angle of periapsis, E is the eccentricity, K is already composed of lot of parameters. K is equal to 2 pi a sin I p root 1 minus e square, where a is the semi-major axis, I is the inclination, and p is the time with this equation by putting the parameters. We can compute the graph between the radial velocity and the two anomaly theta, with the eccentricity and the omega values. We see that when the angular periapsis changes, the starting point of the phase, we can say, also changes. When the uh, when the angular periapsis is 0, then it is starting from here. When the angular periapsis is steady, the it is the point at which the starting is lifted. There is a fixed change. There is flag behind the graph. So then I have plotted linearity as a time plot using this equation, where the d is the gravitational constant and mass of stars and the mass of 51 galaxies B. 51 galaxies star. The graph looked like graph will be looking like this. And with the long target periodogram analysis, we plot the Fourier-like power spectrum we took the data from the NASA website, which is the radial velocity was time plot. Not, nothing can be uh, extract from this data. So we use the log kilogram analysis to measure whether there is a periodicity in the graph or not. In this case, the measurements are unevenly sampled. So when the measurements are unevenly sampled, we use the Lomskag kilogram analysis to know whether there is a periodicity. This is a this is the Lomskag analysis with the frequency on the bottom and the probability of periodicity in the y-axis. We can see a deep peak at the top, and it has the corresponding to the 0.25. So just inverse it to get the time period of the planet. The time period of the planet is found to be the 4.22 days. By trial and method, we find the other parameters like K star, eccentricity, and angle of periapsis, etc. It is possible to find best fit of data with respect to the synthetic model of the equation of Arabic very realistic. By analyzing this model, we get the E value by keeping close to zero. By fixing the K star and omega and taking the E values, the best fit can be measured. Then fixing the E value, eccentricity value, and omega, and changing K star, we get the best fit of K star and can be measured and so on. The best fit is found to be eccentricity is equal to 0.014 and the K star is found to be 56.14 meter per second and omega is found to be 30 degrees. And the periapsis is found to be 30 degrees by using the established by using this equation. We can find the mass of the planet, like mass of the planet, sine value of English is equal to period of P divided by 2 pi g raised to 1 by 3 K star 1 root of 1 minus E square is the eccentricity and M star mass of star raised to 2 by 3. by substituting the values that they obtained. The mass of the planet 51 Augustus DE was found out to be 8.45 into 10 raised to 26 kilograms, which is the 0.452 Jupiter mass, which is close to the established resource, which is 0.4. So the period is somewhat similar. So this is what I want to communicate with you. Thank you.
Hello, Varun.
Yes, yes.
So can we start the Q&A?
No, Rutik, let's hear it from the mentors. So, first of all, I would like to invite Jyoti Basar to make a comment on Arya's session, our presentation. Before that, congratulations, Arya. You have made a wonderful presentation. And most of the students were interestingly asking questions. And even though the younger students from high school standards were engaging in the question answer session of the Google Meet. So I would like to invite Jyoti sir to make a comment.
Yeah.
Yeah, okay. Arya, can you hear me?
Yes.
Arya, the main reason is I attended this session is to meet you. I haven't seen you for a long time. Even okay. So it has been nice seeing you, and this has been a wonderful talk. And the area is slightly unfamiliar to me, but whenever somebody talks about universe and vastness of universe, no, it's all a thing of awe to me. I mean, I get all excited. Okay, so when you talk of planets, I mean, I've been thinking of planets all over the universe. Okay, you have millions of trillions of stars, and everything as a planet. And the kind of questions you ask must be referring to all the planets, right? I mean, can there be life on any planet of any sun in any galaxy? Okay, profound questions, and I mean, in fact, habitability is the possibility of having life, and is there already a developed life somewhere? Who knows, right? I mean, there may be a planet sitting somewhere with a civilization and everything as ours. Who knows? I mean, I don't know. Okay. It has been a wonderful talk, Arya. You have collected a lot of details, and too many details, and especially the last portion of your talk with all the graphs and fittings, and it has been wonderful. You've done a lot of work, and you have arranged everything properly, and it has been a pleasure watching you giving this talk. All the best, Mole. I mean, keep doing well, and we'll see sometime somewhere. Okay? All the very best.
Thank you. Thank you, sir.
Thank you, Jyoti sir. Now we can't move without getting comments from other ISRO veterans joined with us who have been supporting us throughout our history. So let me welcome dear Rangarajan sir to make a comment on Arya's presentation. Sir, please.
Hi, Arya. It's a great pleasure to listen to you. I have seen you grow up from a very little girl to this stage where you're giving an authoritative speech. It was a remarkable lecture, and it shows your deep understanding of the subject, and your presentation also was perfect. In fact, I want to borrow your slides and make my next presentation on atmosphere. And it is real motivation for all of us in coming on this International Women's Day. Yes, I congratulate you and want you to achieve great laurels. And I will be there, sitting in the front row and clapping. Thank you very much. Congrats.
Thank you, sir. Thank you very much.
Thank you, Rangarajan sir. Thanks for your remarks. And let me move to PJ Bhatt sir. Bhatt sir, can you please make your comments on Arya's presentation?
Yeah, Arya, first of all, nice seeing you after such a long time. I mean, I didn't have the opportunity to personally meet you. Thank you for the excellent talk. It was, your presentation or your explanation, everything was so good. And in fact, your aspects of covering on the habitability, including aspects studies on surface feature and habitability factor, dependence on what factors does it depend. So many things you have gone in depth, in fact. And then later, what impressed me much more was your internship project, which you did with respect to 51 PegaCB. I mean, I see, really, you explained it so well. And many things today, there are certain things which I didn't know, I came to know from your talk. Things like, having a larger moon also helps habitability, which is, I was not aware of this. And then something like when planets form, every planets, when they form, they get the primary quality called a primary atmosphere. I was not aware of this also. It looks so, by listening to people who are in a particular domain, they study well and study more, and listening to such talks, it helps. Arya, you have done a great thing by educating me on several aspects. And as Dr. Rangarajan has told, I would also be one of the persons trying to borrow slides from you so that it helps me in my talks. Okay. Thank you, Arya. Thank you so much. Wish you all the best. Thank you.
Thank you, sir.
Thank you, sir. Thank you. Now let me move to Sri Sundaramurthy sir. Sundaramurthy sir, please make your comments.
Good afternoon to one and all. I have no words to tell about Arya's presentation because we were seeing her from the girlhood days. So the progress is so phenomenal, and now the kind of a presentation which she has made, it is really quite informative one. A lot of things I learned from the slides and whatever she has covered and other things. And probably I may not be able to absorb all the things, but to some extent, yes, I could get some of these things which, in fact, when I go for some lectures, the students used to ask me about the habitability and the atmospheric presence and then how that is been. I think now probably I can answer some of these questions based on your presentations. Okay, all the very best for you. I think on a Women's Day, I think we all have been given a very good talk by you, Ma. God bless you, and I pray God you should reach very great heights, and then I wish you should be one among the world-class noted scientists on the planetary aspects. Congratulations. Thank you so much, Ma.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you for your kind regards. And we are very happy with the presence of veteran scientists like all of you who have been supporting us and guiding us throughout our journey. And we know that because of Arya's presentation, with Arya's name, we got so many new participants, new experts who is being joined for this particular session here. And we would like to convey our regards to all of them. And before moving to the question answer session, I would like to request Kutti sir to make a comment if possible. Sir.
Thank you, Varun. It's been an exciting time for me sitting here in the afternoon today. And I have seen first Arya in a 7th standard. and I had the privilege and the pleasure of moving with her for such a long time. And I am so excited that she is climbing heights and heights and reaching the top of the scientific world. And I have, you have heard Dr. Jyoti Basu, Dr. Rangarajan, Batsap, Sundaramurthy, and all. They have all said that the crux of today's program is an exciting, excellent program. My throat is bad, that's why I'm not able to say much. I am compelled to stop it here. But then I am so privileged and a blessed person to have known Arya for such a long time, holding her hand and walking with her. And she is doing an excellent job. And today's talk is really marvelous. And I understand our Shajil, who used to lead all these program webinar, he is away. He was in London Museum as a Government of India delegate. 10 teachers were selected from all over India by the Government of India to go to London, and he is on his return journey. He is in a flight now. Even then in the flight, I saw him looking at our link and trying to catch what Arya is saying. So it's that kind of interest all of us got in Arya. And Rishika, you have done a good job, and Shruti also. So thank you very much. And it's been a very, very day for me. Yeah, I will not forget the day. Such a nice talk. Thank you. Congratulations, Arya. Thank you very much.
Thank you, sir.
Thank you, sir. And the entire team of UL Space Club feels so proud about you, Arya, about the regards you are getting and the presentation that you have done today. It's really informative, and we feel so proud about the comments that our mentors have made on that presentation. And with the permission of Kutisa, before going to students, I would like to invite one more person to make the comments. Ashika, if it is possible, Ashik Yusuf, can you make a comment on her presentation, please?
Hi, Arya. Nice to meet you. It is a wonderful talk, and it's such a privilege to listen to you. And this exoplanet research is one of my favorite fields in astrophysics. And your internship work is so good that if I memory is correct, few years back, Michael Mayer and Didier Colles won the Nobel Prize for discovering Pion Tagashigi. And your calculation is so good that the result they got is matching with your result also. So it's a very wonderful work, and also all the best for your future endeavors. Thank you, Ajay.
Thank you, sir.
Thank you, Ashika. To all other participants, Ashika is one among our team members, and he is currently doing his PhD at BARC, Baba Atomic Research Center under TAFA. And now, with the permission of mentors, let me move on to the question answer session with Rutik. Rutik, over to you for the question answer session.
Good evening, ma'am. So, ma'am, there's few questions from all of us. So, first question is from Adil Prajesh. So, his question is, why gas giants have rapid rotations than rocky planets?
Because it is a good, first of all, it's a good question. The gas particles move fast than the solid, so all the constituent particles are gas. It can move faster. It can rotate faster than the rocky, because rocky substances are the interaction between the atoms are so tight so that it cannot rotate faster. We can from our slides one second, can I expression the screen?
Can you repeat, ma'am?
Yeah. The so the particles so the components in the gas phase are in the gases form. Like gas and liquids are very the interaction between the molecules are too loose, and hence when it can move faster. Like we can water and few solid things which will move fast in the case of rotation. Water, no. So the gases will move faster than the solid. That is what why the gas will have a rapid rotation. I think that is the answer to the question.
Okay, ma'am. Thank you. So the next question is also from Adil Prajesh. So his question is,
Ratik, just a minute. You can invite the students, if possible. You can, if they are here, you can invite the students directly to ask their question to Arya. It
oh,
will be
okay.
more interactive. So you may invite the students as per the order they posted the questions.
Okay, sir. Adil Prajesh, are you here?
Yes, yes.
So can you ask the question?
Ma'am, my question is, uh, what is the actual color of Uranus?
Uranus have the bluish color because it's a gas. Not because it is an ice gas. It has the bluish color due to the presence of methane gas. Uranus has the bluish color. We can see from the NASA observatory, there is a lot of pictures of Uranus taken by various missions like Voyagers and Voyager 1 and Voyager 2, Pioneer 10, etc. We can see the pictures of Uranus. It has the bluish color due to the presence of methane. I think that is what you asked. No.
Okay, thank you. I asked this question because I had heard somewhere the Uranus actual color is green. That is why I asked you. I asked you.
Green is blue, actually. Not green. Not exactly green. 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 Green is blue color.
Okay, thank you.
Thank you, ma'am. The next question is from Anushri Envy. So, is Anushri Envy here?
Ma'am, my question was why so certain planets
Yeah.
have subsurface ocean?
Which?
Anishri, can you repeat the question?
Yes. So, ma'am, the question from Anushri was, can't the satellites of planets have subsurface ocean?
Yeah. The satellite of the planet. That is what I said. The Europa case. The Europa has the subsurface ocean. Europa is the satellite that orbiting the Jupiter that has the surface ocean, which we believe we didn't confirm it yet, but the evidence shows this hypothesis. I think that is not the answer.
Okay, ma'am. Thank you. So, the next question is from Adidev of class 8. So, is Adidev here?
Yes, hello.
Uh,
My question is, could a hypothetical methane-based organism live in Titan's oceans instead of traditional water-based organisms like on Earth?
Yeah, it can be possible because the only living organism we know is on Earth. We don't know what the variety of species can be exist in various worlds. So it is also possible to have the lives in the extreme condition also that will be different from ours. The methods and the processes of life or the things may be different. Yeah, like respiration, photosynthesis, or the chemical processes, chemical composition, and all will be different except others because they adapted to the live in that condition. So that is what you're asking, right?
Yes.
So can we move to next?
okay, ma'am. So, the next question is from Sanjay Krishna of 9th standard. So, is Sanjay here?
Yes, sir. Ma'am, my doubt was that why super Earths are larger than Earth? Is it because of the thick atmosphere?
It is the category that the supers are there. We call the super when the size is larger than Earth. So the size smaller than Earth is also possible, but we do not call it as super because that is we define it like that. The size which is larger than Earth is not that super. That is the definition. I think that is what you're asking, right? Or
Yes, ma'am.
anything else?
Nothing, ma'am. Was the reason.
What?
Ma'am, I think he said that that's the answer.
Yeah, okay.
Thank you, ma'am. So the next question is from Shankar Brahmadattan. So his question is, how is the primary atmosphere lost and what type of atmosphere does current Earth have?
The primary atmosphere is composed of hydrogen and helium. So that will be a tip due to that thermal excitation. Gases like hydrogen and helium will escape into space because of low mass. They have the capability to hold the hydrogen and helium like light-weighted elements because they have low gravity, so they will escape. So the primary atmosphere will be dominated by hydrogen and helium, will be escape out. I think that is what you meant.
Okay, ma'am. Thank you. So the next question is from Sadin T. So is Sadin here?
Yes, sir, I'm here. So can you please repeat my see my question as I am not able to see my chat.
Okay. So the question is, does Mars have only the secondary atmosphere?
Yeah. Mars has only secondary atmosphere due to the volcanic eruption release carbon dioxide. They have detected the amount of methane very large, and there is carbon dioxide also. So they may be the secondary atmosphere. Almost sure. Yeah.
Okay, ma'am. Thank you. So the next question is from Abu Bakr. So is he here? Hello.
Hi.
Okay. Hello. Is he here?
I think Ritik, let's move on to the next one.
Okay. So the next question is again from Anushri NV. So can you please ask the question? Okay, so I'll ask the question. So, does gravity play a role in determining if a planet is going to have primary atmosphere or not?
Gravity mainly plays a role because the gravitational when the nebula gets formed into the planet, the atmosphere is mainly contributed by gravity. Gravity can put the elements in the atmosphere together and form the planetary atmosphere. Yes, gravity plays an important role.
Okay, ma'am. Thank you. So the next question is from Sadin T. So his question is, can life exist in a planet which revolves around two stars?
What?
Can can life exist in a planet which revolves around two stars?
Maybe because like you are in the binary star system, like in the T-body, there is to be T-body problem, like the like the first one single star system. If there are three stars look located Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. But here only two stars. So there may be other factors that can contribute to the stars and how the orbit of the planet is the involved. How the planet orbit the binary stars is an important factor to determine the possibility of life and all the habitable zone criteria will be sustained in the in that planet. So it is a rare possibility, but we cannot say that clearly because there is a possibility, but a least possibility. The possibility is too small because the weather condition will be extreme. So the habitable situation cannot be easily maintained. Cannot be maintained. So that is that thing is. There are other factors also to determine the binary star system. Now, it is an interesting question, but we need to find more than one reason. There are multiple possibilities. So that is not the answer is there is the answer is okay?
Yes, ma'am.
Okay, ma'am. So thank you, ma'am. So the next question is from Adidev. So is Adidev here?
Yes.
Okay.
Ma'am, why does volcanism die down on some planets like Mars? Mars has a ton of extinct volcanoes. Why do they go extinct there? And could it theoretically happen to our Earth in the distant future?
I didn't get your question.
Could volcanism die down on Earth in the future, like it happened on Mars and the Moon?
cannot be in the distant future because the man is still in the molten state. The internal heat cannot be slowed down. Internal heat will be sustained in the Earth and Venus, so they have higher activity, geological activity. Because of that, there will be higher chance of the volcanic activities. So, like Mercury and Moon, they are cold. They can be geologically inactive, and hence they do not do not have the volcano because the internal state is so cold. But in the case of there will be still magnetic field, and the rotation of the molten state is still going on, so they may not be happen in the distant future. Is that the answer to the question?
Yes, thank you very much, ma'am.
Thank you, ma'am. Archit Iyer is having a doubt, so can you ask the
Yeah,
question?
ma'am. Okay. So, ma'am, my doubt is very simple. And I have heard that a recent planet called Hygiene type. It's a planet categorized like Hygiene type. I do not remember the planet's name, but it's an Hygiene type of planet and it contains DMS, dimethyl sulfide, which can only be produced by bacteria or organics. So, why Hygiene planets are very uncommon in our universe? We have only found it only one Hygiene planet we have found. Hygiene means it's hydrogen atmosphere and water in the land on the land. So why it's very uncommon in our universe? I want to know that.
It is because of the universe is very big. When our observation is so too small, within the observations, we find the planets which are orbiting mostly the Earth. They are not commonly the ice gen. So we cannot find we can find one or two planets in the ice gen, I think. So it is because it is of the need for the observation. It clearly shows the importance of for the observation that leads to the finding of the planets. Now it is only 200 or something that we have discovered. We need to find more. That is the reason behind it.
Okay. And I have another question.
Archit, let's just a minute. Arya, let me intervene. How many questions would be possible for you to take more? Shall we stop by one or two questions, or
Anything like anything is possible.
it's up to you, Arya. If you are comfortable, we can take one or two questions, or else we can continue the discussion later in our platforms, our WhatsApp group or something.
Yeah, we can go to WhatsApp group and yeah, this is fine.
Okay. Archit, let's continue the discussion in WhatsApp group, and other students can also participate in your discussion. I hope you are already there in the WhatsApp group, right?
Yeah, I am the WhatsApp group. Yeah.
Yes, Arya, and we will encourage the discussion with other students as well. Arya, you can also help them to understand more. Is that okay, Arya?
Yeah, fine.
Okay, Arya. With your permission, let's conclude the question answer session. Can we?
Yeah.
Yeah, okay. So thanks to all students. I personally know that few standard students also participated in the question answer session in a brilliant way. Those who were selected by Kutisa during his last session at the school, and they are also participated in the best way. So without any delay, let's try to conclude the session. Before that, I just want to convey our regards to all ISRO veterans who are joined with us today, because we know that we couldn't mention everyone's name, but just let me call YVN Krishnamurthy sir, as he is right now here. So Krishnamurthy sir, can you make a comment?
Yeah. First of all, I'm very happy. You're able to hear my voice?
Yes, sir. We are able to hear.
Yeah. First, I should compliment Arya Raj. So, for an excellent presentation, God bless you. And definitely one day you will find something new what the human beings could not do. Okay? Good luck to you. It's especially your question answer session was so good. Keep it up. It was a pleasure hearing to you.
Thank you.
Thank you, Edwin, sir.
Thank you, Dr. IVNK. And
Yes,
you know,
sir.
I'm reminded of your presence in Trivandrum. You know,
Sir.
when we honored Arya and all that, and
Yes, sir.
it's an exciting thing, you know, that you are there today with us to listen to Arya. Thank you very much, IVNK sir.
Thank you, sir. God bless, sir. All the best.
Thank you, sir. Thank you for blessing us with your presence. And I would like to convey our regards to all ISRO veterans. For some of them, we couldn't let them interact with the students. So we would like to get the support in our upcoming sessions. So we will request the participation and support and guidance throughout the journey of UL Space Club. And without any further delays, let me welcome Abhinav, who is one of the prominent students of UL Space Club and the curation coordinator of UL Space Club, to express a vote of thanks. Abhi, over to you.
Thank you, Varun. Now we are coming to end of more than 1.5 hour session, and which comprehensively covered almost everything we have to know about the habitability and the exoplanets, almost everything. And if we can measure in a quantitative way how successful a session, the one of the things we can look at is the interaction, the amount of interaction. If you look at the amount of interaction today, the sheer amount and the diversity of the questions asked in the chat box itself is a testament that how successful today's webinar was. I think this is one of the greatest, if not the greatest webinar. I have no doubt, unarguably one of the greatest webinars in our whole of the webinar series. And the amount of questions still remaining there unanswered, we promise that you can take the questions to our WhatsApp groups, and we will take that questions to Arya and we'll give you the answer. So if anyone have any questions, whether you asked in the chat box or not, you can take it to our WhatsApp groups and we will give you the answers. With that promise, we are going to, the duty bestowed upon me is to convey the vote of thanks. So the one prediction I'm going to make is that we are all optimistic that somehow we'll find, with the exponentially growing technology and all that, we'll somehow find a planet which is at least habitable for humans if we can relocate to there. And that planet will be rotating about one of the stars in the myriads of the stars that decorate our night sky. When we are going to find that stars, whether in this millennium or any other millennium or any time, one of the key contributors to that invention or that discovery of the habitable planet or any type of life forms in another planet, one of the key discoverers or who led the light to that discovery will be Arya Raj, and we will be witnessing her great inventions, upcoming inventions in this area. And with that prediction, we are going to wind up today's session. I'm very thankful. I convey thanks to YVN Krishnamurthy sir, Rangarajan sir, Bhatt sir, Jodhibal sir, Kutti sir, Jairam sir, Shajil sir, Sriram, Varun, then Rashiga, Sruthi, and all the participants, those who are came here. I heartily convey my thanks on behalf of UL Space Club. Last but not the least, the star of the day, our presenter Arya Raj. I convey my thanks. We are part of UL Space Club family. Even though we formally thank you for the sessions, this is one of the greatest webinars, and this will be remembered in the history of our webinar series as one of the greatest. And with that, we are going to close today's webinar. Thank you all the veteran scientists and all the participants. Once again, thank you on behalf of me and the webinar committee and the UL Space Club. Thank you.
Thank you, Abhinav. And those students who couldn't ask their question in today's question answer session, they can directly contact UL Space Club through the mail ID that we send the program link to you, or else through the mail ID of ulspaceclub@gmail.com. You can contact in that mail ID as well. You can reach out to us. You can ask your questions, and you can also be a part of UL Space Club ecosystem. Once again, thank you, Abhinav, and all other members. So, with the permission of Kutti sir, shall we wind up today's session, sir?
Certainly, please go ahead. Please go ahead. Wind up.
Yes,
Let us wind up. Let us wind
so,
up.
once again, thanks to all. Thank you all. Let's wind up today's session. Thank you, Arya. Thank you, good sir. Thank you so much.
Bye, Arya.
An excellent one. Thank you.
Kutti,
Okay, Arya. Bye.
Yeah, bye.
We'll see next face to face. Maybe in Calicut or Trivandrum. Okay.
Okay, Kutti.
Okay,
Bye.
okay, Jodi. Okay,
Yeah.
Jodi. See you.
Bye-bye. Bye.
Nice. Bye.
സാറേ ഞാൻ ലീവ് ചെയ്യണേ.